Yeah, just wonder maybe let's start off. Who of you is working in any standardization activities? Standardization activities. Okay, there's one person, two, okay. And who is aware of standards that you are using? Okay, that's even better. Yeah, we are in OGC are looking for the let's say next generation of the standards and how they will be defined, how can we contribute, what are the actual struggles when we are defining those standards. I'm from the Collaborative Solutioning Innovation Program, leading these initiatives mostly in Europe, but not only. And I'm closely cooperating with the standardization program and also with this development relationship team. The presentation is actually a contribution from the Jonah, Simon, Rob Atkinson, Andrew, Pilar, and a little bit of myself. And I will show you what are the ideas and what are the, let's say, progress in that building blocks. Kind of introduction of why do we work on that. Yeah, first of all, yeah, we are working in different domains. That's mostly geospatial information, but that's already used in multiple sectors, and naturally, not only every sector, but every maybe agency, maybe some countries would like to define they have their own needs in terms of using the standard. So there are ideas, okay, let's extend the standard, and actually you can do that. There's this application extension that you can use. And then you want to use it in the open source software, it doesn't work because it's just not supported, and you don't even know how to compare that. So if you have two extensions, this is really hard work and boring actually to go through all of that dependencies and try to map these different pieces together, how they're represented on the technical level, on the building level, and how to reuse that. So, on one hand we say interoperability reduce the cost, also brings this additional value so you can reach out to more customers, to more communities with the standards. So that's like a scaling factor. So we define those requirements. Then they have different aspects, and usually they, as we recognize, they are over-specified in some of the areas, under-specified in the other areas. So we need those kind of extensions, and then we have these different aspects of the interoperability. So there is an API that allows you to harmonize what is the behavior of different components that are using the standard. So I'm querying the data, I'm discovering, I'm accessing the data. That's let's say behavior. Yeah. Then you have the schemas that are somehow related with the models. So the models is what we understand the meaning of the data. You have different representation of the data in the models because you have different understanding of the data. And so you can use so well-known observation, for example, representation like we have the ISO-OGC observation measurements that already specified somehow, but naturally that's not the only one that is used. Take the catalogs, you have now, I don't know how many standards for the catalogs. We were just talking like now, okay, I just learned that there's a new DCAT AP Swiss version of the GeoDCAT. With GeoDCAT is still not standard actually, but there are these efforts to define, because actually everybody has their own idea of how it should be built. So I will go through several of these considerations and how do we envision of these building blocks. Building blocks naturally is also something that have different meanings. So let's stick to the idea that the building blocks is the, let's say, granular component that can be reused in different implementations. Can be software, can be schema, can be data model, can be API, can be part of the API, can be encoding. All of that stuff can be a building block. But it shall be somehow simple. Then you can have aggregates of that, but that's let's go not too far. So, are you familiar with the OGC APIs in general? So yeah, some of you are. So if you are familiar with the standards, you know that the standards have structure, and they have the conformance classes or requirements classes, so set of the requirements. Then you have the requirements. That's already kind of structured building blocks of the elements. And then you have the standards. In the standard, you can implement part of those. So take the very simple API features, which is the geospatial vector representation exchange. And yeah, that's already have 4 parts. So you can implement only one of them. You can implement as you wish, actually. Naturally, you have to implement the first part, which is core, that structure, the organization of the data, and key properties of your data. And then if you want to use different CRSs, then you extend it with this CRS part. If you want to have more fancy filtering, not based on the queryable parameters, you actually implement the CQL. And then if you want to modify the data, so crude means create, replace, create, read, update, delete, yeah? So if you want to use these functionalities, that's not usually required actually. You can do that and say that this is implemented. And what's good is that the standard implementations already need to declare what they are implementing. So if you open the standard page, or if your robot is accessing the web page which is implementing the standards, the API, you already know which parts are implemented. In general, because they can vary in the implementation of the requirements. And let's go further. So we have the part that's now extracted as the API commons. The commons part are this first attempt to define these building blocks that will be reused all along the other standards. That's inherited from the features, and that was extracted to the other standards. And then again, you can extend, so based on the sum of the same common, you can have vector representation, but you can also have tiles, you can have EDR, and EDR also can inherit the features actually. That can be reflected when you, okay, what does it mean? So we have the web page, and that's exposing different data. So that's example. You have this access to the data, that's just part 1, but you have these tiles implementations already of the same set of the data. It's in here, so we have the rasters. You can implement your styles, and you have also this common part, which is a description of the API actually in this meaning. So you have the common part that has the common model of the API description. But now we go further, and kind of a good example of the building blocks as we perceive that is the bounding box. Because everybody is using bounding box if you want to narrow down to your area of interest. And on one hand, that's common, and that's well represented in the implementation, so on. Then if you use the bounding box, you may know that even the order of the coordinates can be whatever you want. But this can be the ideal example of the bounding box. That's what we started, like the next generation of the bounding box definition. So in the definition, we mean that we have exactly the documentation of this element. It has this HTML nice representation, so you can aggregate these different examples. How can we use that? That's also maybe for you, maybe for the people who are willing to implement their own standard, because we know that there are also plenty of the standards that are not OGC, like NGSILD is quite popular in Europe now, so they also have the location. But the location is actually something that they define and don't even reference to what that means. And the same with the feature of interest. What does it mean, the feature of interest in NGSILD is something that you can find somewhere in the documentation, maybe, page something, 115. And if you miss that, you don't really understand what's behind the data. So, we have the standard of publication, this kind of components, that's ISO. That's a little bit more too complicated. So we are now working on the register of these building blocks that's quite simplified. It follows this 135 standard of the publication of the elements, but that's simplified. So we have just this three entities. We have the item that defines what does it mean, this building blocks. We have the relationship, we have the status, because some of them can be proposed and some of these can be already major. And then we can naturally have the implementation and examples. We are following the best practices of the linked data, which means each of these building blocks is naturally somehow identify entity itself. So if you are referring that your data element is the bounding box on your data model, you can refer strictly to the URI, which is Unified Resource Identifier, and that's the unambiguous definition of that element. And naturally, we have different needs on that description. So we have a human-readable description, like the Markdown. We have the JSON that structure the schema of that element. We have the examples because people need examples. How do they actually work? And not everybody is capable of willing to read the documentation. If there is an example, that's quite common shortcut. And then there is a schema. And I will come back to the schema because that's a very important part of the topic. Then we have also the assets and the tests. So we have now in the OGC this IT environment, which is providing you the validation mechanism. So if you are implementing your services or exposing your software, you can run the Site team engine from OGC, and that will check if your interface is compliant with the standards on some level. You can then apply for the certification. If you're a member, also you can do it online. And that's the example of the more complicated, but not so much, building blocks. There's a standard that tries to define the position of the element in the space. So take the drone. Drone is flying object, so it has the location, but it has also the pitch. It has this all orientation elements that can be expressed in this here. So it works? No. Okay, so you have this example of the element of the geopose simple definition. So what does it mean? We define the longitude, latitude, height, then we have the rotation, which is somehow also defined in the standard. But then those things shall have the meaning. So what does it mean? The longitude is not specified here yet. So the idea is that some of you may know that there is this JSON extension, which is a JSON LD. JSON LD is kind of naming space. So you can define what are the meaning of those elements. So like the longitude is coming from some of this definition. So here we have namespace geospatial, and if we will use that lat instead of latitude, then we know that it's coming from the geopose definition of those. Yeah. And then we can also annotate the payload. So we are not only that's not only for the definition of the API. That's for the definition of the data. So if we provide the context definition together with the data, we already know what are the meanings of these different elements. And if we have longitude from geopose and the features and the EDR, if they would have one common reference point, then it will be just simple to understand what does it mean. And the schema is also important because the schema can be used for the validation. So if you have your APIs that defines what building blocks it's using, then you have referred to the schema, and then you can easily run the validation of your API. And as the validation is in the morning that actually sometimes we have the payload, and if we want to make it really reusable, we need to add this meaning to the data. And that's usually not coming from the open source, because the open source is generic. We are domain specific, so if we want to add this meaning to the data, we usually semantically uplift the data. And that's really is part and the key element and the key value of this semantic enrichment that needs to have these building blocks definition. So there's I will not go through the pipeline, just to mention that there's an entity in OGC called naming authority that's accepting all the elements in the standards, and that's also committed to support these building blocks. So actually, if you are defining your own extension of the DCAT, or you want to have your own extension of the features, first look into the building blocks, because maybe there's something that was already defined, maybe that's worth to reuse that. Then if that's not, if you think that's useful, especially if you have the implementation, push that. I mean, you can open the issue at the GitHub and propose that, so others will reuse that, and others will actually use the same definition, so you will not get into troubles when you go to the implementation and especially that if you are using the software, then you will just skip the gap of this reiterating on the understanding of the data. So there's a GitHub, there's an open issue page. You have also the website, which is building blocks, blocksogc.org, and then the idea is not only to define the building blocks, but ideally to guide people what kind of standard should they use for their needs and what kind of elements can be used for that. So that's time's up.
Okay, thank you, Piotr, for the great introduction.
Questions?
Yes, stay here. I guess there are questions, and so are there any questions to Piotr about building blocks? So I'm curious about where you promote this approach. You go to these events like Phosphor-G and you promote them on other sites as well?
Yeah, now we have promoted it along these weeks and these working groups, which was successful because they contributed to the work. So they already, and we are just, the OGC staff. We are just facilitating this kind of work. The knowledge is always coming from the community, like this one, like OGC community, that really have this knowledge about these different cases. And we need to promote it in this kind of open source community. Well, one of the ideas is validators. So maybe that's a value in itself. We have experience in the project that we support directly the implementation that this kind of validators could be useful. So if you are defining your own features for the marine environment and you have like 20 pilots that have their own definition of the things, we are trying to align that and to try to use these building blocks in this kind of approaches. That's now also the exercise, that's true, but also the recent requests actually to OGC is that standards come with the validation. So there are not all of the standards are actually given with the site environment, so you cannot run all of the tests against your implementations, and this should help. I mean, this is an effort because you need to build that. If everybody has their own schema, that's just repeatable effort. You need to review that again and again and again and again. If you have these building blocks, that's just easier. So definitely in the working groups and in the implementations, we're also running these pilots. So that's open. The OGC testbeds and pilot are pretty much open. Then if you sign up, if you are selected, you can take part in this kind of exercise to prove the interoperability of the implementation. That's one way.
And maybe another question to the audience: if there are developers around, are you interested in this approach, or do you think it's valuable? Maybe some feedback from you. I see someone say yes, or
yeah, that needs to think through, but you have to listen to feedback like offline also.
Yeah, one thing I was wondering about, because you were talking about like extending the CAT with your own needs, but what we've been experiencing is that like regional governments they are trying to narrow down the standards. For instance, we now have to follow something called DCAT APNO, which is like the Norwegian version, and it's probably a Swedish version as well.
Yeah, I guess so. I would say that's the over-specification of the standard. So if we could have identify this core and these extensions based on your experience and the other experience, then we can say, okay, this is the building blocks of the like core of the DCAT, and these are the extensions. And then in the API, you can just say, okay, I'm using this and this and this and this, and that's already useful. Yeah?
Yeah, so it looks like community is important to get involved in
yeah, community is good, naturally. We just see this as a community base. We are not nothing without the community. Thanks for all that's involved in that activities, and that's thanks to the community that we have those. That's we actually boost the geospatial technology.
Okay, so I want to thank you again, Peter, for a nice talk. Applause.